Good day and welcome to this episode of Applied Electricity. This is the second part for the second year engineering students, and in this part we are going to be dealing with mostly the practice questions. So under this course, Applied Electricity 2. So some may know it as EE202. So and we are going to be starting with the first topic, DC generator and motors. So we are going to be mainly focusing on the practice questions in order to broaden our horizon and let us know about what we are going to be meeting in exams and tests. So before we venture into these questions, I would like to give some formulas that has to do with DC generator and motors. So they are going to play a vital role when solving these questions. Firstly, for generator, for generator, um, our voltage is always equals to the EMF minus IARE. Now, what is IA? IA is the armature current. They call it armature current. Then RA is the armature resistance. So that's for the generator. For the motor, for DC motor, we have V is equals to the EMF, that's the electromotive force, which is also in volts, then plus IARA also. Now, you can see the difference between them is the plus and the minus, but you have to take note that if you are using V as your subject of the formula, it means that your EMF will be subtracted from the IARA. That's for the generator. Then for the motor, it will be the EMF plus the IARA. And what is IR? It is what? Volts. So it's like they are saying the volts in the armature voltage. Yeah, because this has to do with armature current and armature resistance. And from Ohm's law, we know that V is equals to IR. So that's just the basic knowledge of that. So now, when we are not given armature current directly from the question, and we are asked to get it from the values given, we can say our armature current equals to the load current plus the field current. Yes, the load current plus the field current. So how do we get the load current and how do we get the field current? From load current, you can say that you can use the electrical power law. And what is the electrical power law? P is equals to IV. So if I say from P is equals to IV, I can make I subject to the formula. So from here, P is equals to IV, I can say I is equals to P over V. So in this way, my load they always give me my power for my load. So and they always give me voltage also for the load. So in that way, I can say my IL, which is my load current, equals to P over V. They always give me in the question. It's very, very sure. Now for IA, this is the field winding, the current in the field winding. So for this one, we are using Ohm's law, V is equals to IR. So if we say V is equals to IR now, I can also make I subject to the formula by saying that I is equals to V over R. So same way, if you are given field winding, you always have the voltage for field current, and you also have the resistance that is functioning in that field current. So that's why we're going to be having the same thing. You're going to be having V over R in this case. So these two will be given in the question. So in case you are not given armature current, but you discover that you were given the power and the voltage that has to do with the load current, then you were also given voltage and resistance that has to do with the field winding current, you can automatically get your armature current. So from there you can insert it there to look for whatever they say you should look for. Maybe you have to look for the voltage or you have to look for the EMF. So now that's for that. Then another formula again is the force required to kickstart a winding generator. We've been used to this formula from past, and this one that say force is equals to BIL. Now what is this? This is the force required to kickstart a winding generator. So basically this is force. This is force. So this B, I'll call it beta or anything you want to call it, but this is the flux density. and it's always in Tesla. It's always in Tesla. So that's the flux density. Then what do we have here? We have the current. So this one is current, and this is the length. Might be length of the conductor, might be length of the insulator, depending on the material they are giving. So I haven't gone through this process. Think we are good to go. This is for generator, this is for motor, and this is armature current. Armature current is load current plus field winding current. Then you can get them. You can get load current using P over V. You can get the field winding current using V over R. Then this is also the one for the force required to kickstart a winding generator. So now let's venture into these questions here. So they said a shunt generator supplies voltage at a terminal pressure of 240 volts. A terminal pressure, that is the voltage, the normal voltage. So we are given V as 240 here. So what were you given again? We were given to a lighting load of 25 kilowatts, that's 25,000 watts. And what is that load? You know, I told us here that if you're given, you might not be given the IL, but you'll be given the power and you'll be given the voltage. Now you see that it has to do with load here. So you'll be having your power. Your power is with 25 watts. Now let's go on. Now the resistance of the field winding. Now come here again. See that for the field winding here, the current in the field winding, I say we can get it by using V over R. We already know V in our equation, but we need the R. Now you already told you that the field winding resistance is what? 80. So automatically you can get this and this to get your armature current. So now we are having resistance of the field winding. Let me see, resistance is 80 ohms. Now the armature resistance, now that is this armature resistance, the RA. Armature resistance is what? 0.16 ohms. Now we have gathered all our data. The core thing that you must take note of is that you have to write your given out. When you write your given out, you actually know which direction you are going to. So now the armature current, you already know that IA is what? IL plus IF. And what is IA? Let me use some black marker here. Our IL is what? P over V, according to here. Then our IF is what? V over R. So it's as simple as that. So you just insert your what we were given in the question. So what's our P? Our power is 25,000 over the volt, which is 240. Remember, we're calculating for IA, the armature current, as they told us to do here. So for the IF, which is the field winding current, we have V over R. What's our V? Our V is 240. Then our R will be what? Our R is 80. So why are we using this R? Because they already told us in the question that that's the resistance of the field winding, and we are dealing with field winding here. So when we calculate that on our calculator, let's check the value for that. We'll be having on this side we'll be having, this will give us 104.17 plus this will give us 3, because this cancel, this will give us 3. So what will be our armature current in this case? Now our armature current will be 107.17. 107.17. It is current, so it is going to be in ampere. Now that's for the first part. Now the second part, the B part, the generated EMF. Now note that we are dealing with generator. So and we have the formula that we normally use for generator, which is what? This here. We are dealing with this. So we already have EMF here for generator. So we are going to make this a better formula. If this whole thing, if it comes here, it becomes V plus IARE. So that we are going to be using. So we'll be saying our EMF is equals to V plus IARE. Don't get it twisted. If it is your voltage that is the sum of the formula for generator, it's going to be V equals to the EMF plus minus the IARE. But when you make the EMF sum of the formula, that's when you now change to plus. So we omitted this before, but this is they said assuming a brush contact total voltage drop of 2 volts is involved, that means all the voltage there must be assumed to be part of the equation. So by that we'll be adding this 2 as the additional voltage. Maybe I will call that one VA, additional voltage, because it has to do with all the voltage here. You know, EMF itself is in volts, so and it is this voltage which is 240 plus this IARA which sum up to be a voltage again, and this additional voltage also must be included. So now let's go into that. So now say our EMF is our volts, which is 240, that's the real voltage drop, then plus our IA, we got that one here, that's 107.7 into bracket. Our RA is what in the question they give us RA, that's the armature resistance, 0.16, then we add it plus 2. Now let's check what we have there. Now answer, calculate that on our calculator. We are having 259.147 here. So then make us approximate 259.16 volts. So that is the generated EMF for this shunt generator. That's the generated EMF. So now that's all for that. Let's move to the second question. And they said a conductor of 300 millimeter long lies at right angle. Now you start picking our given. So what were we given there? We were given length. Now this, I think we are dealing with this formula now. This formula. So we are given length in the question. So we say L is equals to 300 millimeter. Now we convert this to meter. And how do we do that? That's 300 times 10 raised to power minus 3. Why? Because this is milli, and milli is in minus 3. If you convert that to meter, you'll be having let's calculate that. You'll be having 0.3 0.3 meter. So now to the magnetic field of density 1.6 Tesla, that is the flux density. So we're having this as 1.6 Tesla, and it carries a current of 25 ampere. So we're given the current also, we add 25 ampere. Now you have to calculate the force. This is a direct question that you can do without even thinking, because you know the formula already. So F is equals to BIL. Now this is 1.6 multiplied by our current is 25 multiplied by our length is 0.3. It's a very direct question to get. So now on that we'll be having 12 Newton. So that's for that. Going to the last question in this episode, we're going to be doing a question that has to do with the DC motor in this case. Now to refresh our memory, I would like to write those formulas again on this side. So remember for generator and for DC motor, for motors, please put these formulas at the back of your mind. They are very important. So for generator is going to be V is equals to EMF minus IARA. Then for motor is going to be V equals to EMF plus IARA. Now let's deal with this question. We are dealing with a shunt motor. That means we are making use of this here. Yeah. So now a 460 DC shunt motor is 460 volts. So they've given us the volts from the beginning. We write our given out. They're given the volts as 460. Then running on a load has an armature resistance of 0.12 ohm. Now armature resistance, that's RA, armature resistance of 0.12 ohms. And we are asked to calculate the value of the induced EMF. We are looking for the EMF of this motor, and they said the current in the armature is 150 ampere. Now in this case they've given us the current in the armature, that's the IA. They've been given the IA here as 150 ampere. So how do we go about this? We go back to the formula here. So for the armature current, we know this is the armature current here. we've been given the armature resistance, we've been given the voltage, so we have to look for the EMF. So let's invert the formula. This, we can bring this back here. We have V minus IARE, right? So the back EMF, or the induced EMF, will be V minus IARE. Now we insert all our given. The EMF here is the voltage 460 minus, open your brackets, 150 multiplied by the RA, 0.12. Let's see what that gives us. The EMF will be 442 volts. Yes, that's 442 volts. So for the second one, so that is the EMF that we asked to look for, the value of the induced EMF when the current in the armature is this. Now for this, the value of the armature current, they asked to look for the IA. Now in this case, forget about what we have done here before. We are now giving another case. We are still using the same formula, but in this case we are looking for the another armature current. Now this time they give us our back EMF as 485 volts. Now we now have new parameters. Now we have our EMF. Our EMF has been given already. Remember, your voltage still remains 460. That one is fixed. Then you have your RA also. RA also still remains 0.12 ohms. So we can solve for them by using the same formula. We are looking for the IA. So you are making this subject of formula. You bring this here, then you bring this as divide here. So what am I saying? Writing the formulas. You say V is equals to EMF plus IA RA. Now, how do we make this subject of formula? Very simple. Just bring this one, this EMF to the other side. You have minus EMF is equals to IA RA. Then you divide both sides by RA. We have this over RA is equals to IA. So now we can calculate for our IA. So our IA will be what? Our V, which is 460, then minus the EMF that was given in this very question, which is what? 485, then over the armature resistance, which still remains 0.12. Let's see what we have there. We should have minus, yes, minus 208.38. Minus 208.3 ampere. It will surely be negative, because you can see the EMF they gave us here, it is higher than the voltage that was here. So surely we should have a minus here. So that is the armature current here. As we will be doing more questions on this DC generator motors. This is just the first part. Do well to like, share, subscribe, and comment. Thank you very much.